So again, I stuck this in 1.4 because I didn't know where else to really stick it. We're going to talk about the different reaction types there are, and you should be able to recognize them, and you should also be able to write reactions based off the fact someone tells you the reaction type. There are other reaction types we will learn later. For now, this is just intro reaction types. These are the same ones as you learned in Gen Chem if you happen to take Gen Chem. Cool. So, like I said, you should know them, you should recognize them, and use them if they're mentioned. So the first one is combination, aka synthesis. And so we're taking two things or more, and we're forming a new thing. Just a single new thing. So in this example, I have solid sodium metal. So it's a metal, so usually solid. Well, it said solid there too. And so Na. It reacts with chlorine gas, so gas is here. Remember that chlorine is one of the diatomics. If listed by themselves, it's always going to exist as 2. And the product is solid sodium chloride. So here's our solid. I wrote my reaction down. I balanced it out. Make sure it's balanced. Everything is good to go. That is synthesis. So again, if I give you, or the test, gives you, an equation like this, you should be able to yeah, that's synthesis or combination. If it gives you like this first part where it says solid sodium metal reacts with chlorine gas and it is a synthesis reaction, you can guess what the product is and be able to write a product. Cool. Decomposition, we're breaking down into 2 or more substances depending on what the example is. And so in this first example, we have an ionic compound. We have mercury 2 oxide. It's a red solid. Cool. So we got a solid. It's decomposing. So that's why we draw the arrow. When it's heated, and then you're producing mercury by itself and oxygen. Again, oxygen is one of the diatomics we memorize, so that's why it's O2. Mercury is just chilling as one of itself, and so that's why it's 1. And then you want to balance the equation. For example 2, we have calcium carbonate, which is an ionic compound. Ca is +2, CO3 is -2, so you need one of each. It doesn't tell you the states of matter here. I put the states of matter because I know what they are, but in this problem it doesn't. So if it doesn't give you the states of matter, don't put them. If you happen to know it, then go ahead. But if you don't, then don't. So anyway, we're decomposing, so that means it's an arrow. And we have calcium oxide, so calcium is a metal, oxide is a nonmetal, so that's ionic. So Ca is in the column of +2, oxide is in the column of -2, and so that's why I have one of each. And then we're also producing carbon dioxide. That is a covalent compound because it's 2 nonmetals, and so I just do it based off the prefixes. Carbon does not have a prefix, so it's just C. And then oxide has a prefix, di, so there's 2. And then I make sure that this is balanced. I have 1 calcium on both sides, 1 carbon on both sides. I have 3 oxygens on the left, 1, 2, 3 on the right, so everything's good. Single replacement is also known as single displacement. Tomato, tomato, same thing. One thing is replacing another thing, and by thing I mean element. And so when you have a reaction, it's a lot easier to just see the example to understand what I mean. And so here we have a sentence that's just saying something great. Who cares? When a strip of magnesium metal is placed in an aqueous solution of copper 2 nitrate, okay, it replaces the copper. So I actually didn't need this other sentence here because it says it replaces the copper. The magnesium replaces the copper. So that means that I'm going to single replace this magnesium with this copper. That's what it means. Now, in this case, it told me the products, but if I just stopped at that one sentence here, I could have easily written the products down. And so here you could see the magnesium replaces the copper. I want to make sure that my, reaction is written correctly. Magnesium is not part of the diatomic, so there's only 1. Copper is also not part of the diatomic, so that is just 1. And then since it says copper 2, so that's a +2 charge on that copper. And then nitrate is NO3 -1, and so I need 2 of those. And then magnesium is also +2 because it's in the +2 column of the PT. And then NO3 is -1, so there's a 2 there, and then everything is balanced. So there we go. So again, in this case, the magnesium here is replacing the copper 2 ion here, and so that's how we got those products. Now again, this last sentence might not have been written. If they already says it replaces it, then, follow the single replacement pattern. Double replacement is almost the same thing, except we're switching to. Double replacement or double displacement, again, tomato, tomato. Sometimes it precipitate forms, usually it does. We'll talk about that in a future unit, so that'll be later. So we have two solutions. We have potassium iodide and lead 2 nitrate. That's why they're both AQ, because it says aqueous solutions. And so I want to make sure that I see this is ionic, this is ionic. So I wrote these as ionic with the correct charges based off the charges. And then we're forming two products. It tells us potassium nitrate aqueous and lead 2 iodide precipitate. Precipitate means solid. And so seeing this, cool. Again, all of these were ionic, so I made sure that the charges balanced in each formula. After the formulas were balanced, then I had to make sure my reaction is balanced. And so here's a 2 here, here's a 2 here, because I have 2 Ks and 2 Is. I needed 2 nitrates as well, and so that's why those coefficients are in the front. Cool. Last thing, combustion. So combustion is a substance that usually, not always, usually is a hydrocarbon. If I break that apart, hydro, hydrogen, carbon is carbon. So any compound that has carbons and hydrogens in it. It'll react with oxygen gas. Some kind of energy is released. We'll talk about that later in a future unit. And then it forms water usually and carbon dioxide sometimes. So if I'm automatically reacting with oxygen and you're producing two different products where it's not necessarily, a double or a single replacement reaction, then it's probably a combustion. So here you can see propane, tricarbon octahydride, goes through combustion. Since propane is a normal hydrocarbon with carbons and hydrogens, reacting with oxygen automatically makes CO2 and H2O. Automatically. And so if something is going through combustion, automatically you're reacting with oxygen. If it is a hydrocarbon, you're for sure making CO2 and water. And then you balance it out. You might not know the states of matter of CO2 and water. Usually it's a gas, but not always. So it depends. But most likely it's a gas. Cool. This is the stuff that you would use in cars, for example. Or a grill. Or whatever that uses propane. Alrighty. So here's two examples. You're going to write the equation and then identify the reaction type. So go ahead and try this out. Use your College Board PT. See if you got ionic or covalent stuff. See if you got one of the different reaction types and then try to write it. Alrighty. I'm going to go ahead and go over the answers. This one's tricky. So I reacted with oxygen. And technically, when you're reacting with oxygen, it's combustion. So if I go back to the combustion slide here, it says any substance, usually hydrocarbon. Not always. It's just usually. If you're reacting with oxygen gas, you're forming something. And so again, it doesn't have to be water and carbon dioxide. It's just that if it is a hydrocarbon, you will produce carbon dioxide and water. But for this one, it's combustion because, again, technically you're reacting with oxygen, and so therefore it's going to be combustion. Now, it looks like a synthesis reaction, I know. It's one of those, annoying things. But again, most combustions will produce carbon dioxide and water, but not all of them. And so if you have a hydrocarbon reacting with oxygen, automatically it's a combustion. If you have something reacting with oxygen, it's most likely a combustion. I would just assume yes rather than no. Cool. Second one, we have two ionic things and then two ionic things, and the cation switch places. So you could see that the lead replaced the magnesium replaced the lead, and so boom, there we go, double replacement. Ta-da! Cool. Oh, that's it. Okay, bye!